methods over large amounts of data at scale. Many, many problems there. So we worked on this for almost 2 years in close collaboration with many scientists, NGOs, and so on. And in Cancun, in December, we officially launched Google Earth Engine, which is our new technology platform for global scale environmental monitoring and measurement. You can think of it as sort of having 3 parts. First, a data catalog where we're attempting to organize for everyone in the world access to the unprecedented treasure trove of satellite imagery data that exists. Then we want to offer access to thousands of computers in our data centers that right now are running YouTube and Gmail and Google Search. Wouldn't we rather they be running environmental analysis? And finally, we offer a framework for new applications to be developed or existing applications to be ported so they can run at scale much faster than has been possible before. So looking at the data, this just gives you kind of a sense of how every spot on Earth, tremendously useful imagery and scientific measurements are being collected every day from space, from dozens of satellites. There's some spots on Earth, for example, that thousands of measurements have been taken, but most of this data is on tape right now. It's not available. So our first project was to bring online the Landsat archive, the last 25 years of satellite imagery collected over the entire world. We focused on the tropics initially. And what you're seeing is those tallest green bars are where we have loaded into the Earth Engine data catalog online for the first time 100% of the last 25 years of Landsat satellite imagery for those countries. This gives you a sort of our internal dashboard, but you can see that in many cases it's tens of thousands of satellite images that have never before been online or accessible for analysis. Last week we loaded the 1 millionth scene. It was over a part of Siberia. So we bring this data online and then we produce automatically different kinds of mosaics. So for example, countries need to create reference baselines for forest cover in 1990, 2000, 2005. It's very difficult for them to do this. They need to remove clouds. They need to remove problems in the imagery. We do all that automatically, right? So rather than having people spend their time doing that, we can automate that. We talk about going from the ground to the cloud because to do proper environmental monitoring, you can derive certain valuable information from airborne or satellite imagery, so-called remote sensing data, but valuable information must also be collected on the ground. And so we've done some initiatives over the past couple of years, actually using Google Android smartphones that are web connected, that empower local communities and community-based RED projects to collect important forest inventory data. This is an example where we worked with the Jane Goodall Institute in Tanzania to train village forest monitors who were not particularly internet savvy, but they were very comfortable using mobile phones. This is data they collected in the Masita Ugala ecosystem, and you can see they easily collected high-quality forest inventory data. You can bring the data online and bring it into Earth Engine for analysis. This is Mexico's 400,000 points of forest inventory data. And each sample point, they've measured biomass and carbon. And again, that can be then analyzed in concert with satellite imagery data that handles forest area change. And together you can derive biomass and carbon. And now I'm blitzing rather quickly through this, but so the next offering that people asked us for is access to our computers in our data centers for computation. So I thought I would explain to you, people say, what is parallel processing? How does that help do environmental analysis? Imagine that you have a large set of imagery over, it could be for a whole country, it could be for a whole continent. We split that up into pieces. We farm each piece out to a different computer. Each computer runs the analysis over that geographic extent. The results are brought together and stitched back into the final analytical result. You'll see examples of what kind of impact this technique can have in a moment. The final sort of most important area is the actual applications that can be built now on this platform. We've worked closely with Amazon in the Brazilian Amazon NGO who have created an alerting system, a monthly alerting system for areas of suspicious change. This is their algorithm powered by Earth Engine. Working with Carnegie Institute for Science, who have a class light algorithm for degradation and deforestation. We're now working with the Natural Capital Project that does valuation of ecosystem services, water, forest, and so on, bringing that to scale. This is WWF-TNC in Stanford. Finally, you can see going online into the Google Earth Engine Map Gallery results of some of the projects that have already been done. This is one that we demonstrated in Cancun at the launch, developed in collaboration with Matt Hansen of South Dakota State and the government of Mexico, CONAFOR, the Forestry Commission. This is the finest scale forest map of Mexico that's ever been created. It required analyzing 53,000 Landsat scenes, the last 25 years of imagery for the country of Mexico. It took 15,000 hours of computation, but because we ran it on 1,000 computers in parallel, it was done in less than a day. It would have taken almost 3 years otherwise. Mexico is now deriving change products and turning to biodiversity applications. So the last point I wanted to mention in this whirlwind tour is we want to make sure, as Google.org, that there are no barriers to developing world countries using Earth Engine as their developing RED capacity. So we've announced a donation of 20 million CPU hours to the developing world countries, and we are providing technical support and technology transfer to help them develop these capabilities. So the summary is it's a new technology platform. Unlike Google Earth, which is visualization, Google Earth Engine allows you to do environmental analysis at global scale with an unprecedented catalog of data online for the first time. We're still in the extremely early stages, and we're very much driven by what our partner countries and partner scientists request from us, and we've announced this donation. So I guess the last point is, we've found that only through the partnerships we have with the NGOs, with government, with academia, can our work have any meaning at all. And it's been a privilege to work with these institutions, and we look forward to hopefully helping address some of the global challenges of RED and sustainability. Thank you very much.
Thank you very much, Rebecca. If you just be patient for just a minute or so, and then we will be welcoming the President of the Republic of Indonesia into our midst.